Welcome to Module 2 of MathMagic 2.0 Reinventing Calculus. So in the coming lecture, we are going to look to that if I need to assess the velocity at this specific point, either I can start assessing from this direction, that is your left, or from this direction, that is your right. If I am moving from the left, I'll have to start from the lower values and come to this particular point. And if I am starting from your right, I'll have to actually reduce because I'm starting from the higher value and will come to this particular point. We will look that whether the approach from this side and this side, they are matching with each other or not, and they are coming to the output of this velocity at that instance is same or not. So we are looking to a word, and that is change. We also said that there are certain functions which depict the behavior or the rate of change. This means that if there is a function fx, we know that input is given x and that this function is going to give us as an output y. We also know that we plot x on the horizontal line as an input and y the output on the vertical line. Say for example, there is a function. Now to assess that at this instance or at this point where the input is x1, we can very well look to that what is the output, and then the output becomes y1. Today we are going to introduce a concept which is known as limit. Now this limit is pinpointed. This means that it is actually the very close, the very particular observation of the change which is happening. Let us look a wider picture that I've got an input in terms of x and there is an output y which is depicting the output of a function. If there is a change, now I intend, or rather we are going to focus on a particular point where the input is going to be a and the associated output is going to be L. Say for example, the limit is always mentioned as limit when this x, this is the input. When the limit, the input is approaching a, means the approach is towards a, maybe from this side or from this side, then how this function is going to actually give the output in terms of L. Let us actually look a little deeper. Let us say that there is a function fx depicted by 2x plus 3. We need to visualize, we need to look to that what is the behavior of the function when limit, the input or the x is approaching to 2 or maybe say 3. So how this function is going to behave, that is 2x plus 3. Now this can be approached if I draw a graph and if I say that this function is going to give us an output L at this point A, wherein here the A is equal to 3. There are two ways to approach to this particular A. One is from the left hand side, that is from this side, and the other is from the right hand side. In order to assess the limit, let us look to the scenario that if I am accessing this limit from the left hand side and x is approaching to 3 from the left hand side, when it is approaching from the left hand side, it is depicted by a superscript minus, and when it is looked upon from the right hand side, it is depicted by a superscript plus. What does this mean? Say for example, it is 3 over here. When we are approaching from this side, that is from the right hand side, it will be from 3.1 to say 3.01, 3.001 means the 3 is being approached from this side, which is depicted by a superscript of plus. If it is from this side, then it will be approaching from 2.9 to 2.99, 2.999, wherein this is depicted by a superscript minus. This is known as the left hand limit, and this is known as the right hand limit. Let us look to the limit approaching from the left hand for the function 2x plus 3, and our focus point is 3. If I draw the table as we have already drawn earlier, the input value and the function's output. Now if I say that because it is being approaching from the left hand side, so it will start from 2.8, the output for this particular function over here, for this particular input, would be 8.6. You can calculate. You can very well say that when it is 2 into 2.8 plus 3, this output will be given. Similarly, we'll approach closer from the left hand side and make it 2.9. The output would be 8.8. If it is 2.99, means we are approaching to 3 again, the output becomes 8.98. If it is 2.999, then the output is going to be 8.998. If I directly substitute, if I look to it over here, and if I directly substitute in the function 2x plus 3, the value of x, if I directly substitute as 3, it becomes 2 into 3 plus 3, that is equal to 9. So we see in here that it is approaching nearly to the 9 from the left hand side. Now the similar can be seen from the right hand side. Right side. Now if we look from the right hand side, we have already seen the left hand side, and now we are going to approach from the right hand side. This means that if this is the point, we have already seen the approach from this side. Now we are going to approach it from this side. When it was here, say for example 3, it was approaching 2.9, 2.99 and so on and so forth. But from here, it will approach from 3.1, 3.01, 3.001, so on and so forth. And this is going to be depicted by limit x approaching 3 with a superscript of plus. The function, as you all know, is 2x plus 3. Let us draw the table once again. And if I say that the input is this side and the output of the function, now you know that this is the function. If it is 3.1, the output would be 9.2. If you multiply or substitute 3.1 into 2 plus 3, it will give you this output. The closer would be 3.01 and it is 9.02. If it is 3.001, the output is 9.002. So we can very well see that from the left hand side also and from the right hand side also, the output at 3 is approaching to 9. So we look to the limit at the input approaching 3 for the function which is equal to 2x plus 3. And we see that from the left hand side and from the right hand side, you remember that from the left hand side we talked about 2.9, 2.99, 2.999 and so on and so forth. From the right hand side we are approaching 3.1, 3.01, 3.001, and the both from the left hand side and the right hand side, for the input approaching 3, the output is reaching or approaching to 9. This is where the limit comes into picture. We are actually looking to the pinpointed point or the very close or to a particular input for a function.